Welcome to this video of another applied mechanics topic, which is motion involving time, particle, velocity, and acceleration. So it will do us good to branch through all these parameters. That's something that we're already used to. What is time? Time is the duration of an event, and it is measured in seconds, as we all know. So particle is an idealized object. It is not real, though it has mass, but it doesn't have size and shape. So you cannot measure a moment for a particle. It's not possible, because if you want to look for displacement when you are looking for moments, and particle doesn't have size, it doesn't have shape, so it's just an idealized object. So what is velocity? Velocity is the rate of change of distance with time. That is the s dt. We normally denote displacement or distance as s when solving in physics topics like this. Then acceleration is the rate of change of velocity with time. That is the vdt. So concerning velocity, when you are given s in your question and you ask to look for velocity, just know that you are differentiating that s with respect to t. That means you are differentiating the distance with respect to the time, because will already give you the s in function of the time for them to tell you to look for the acceleration, the velocity. Then the second derivative of that s, that is the square s over the t square, yes, that is acceleration. Because when you differentiate it again, you get your acceleration. Normally acceleration is dv dt, that is change in velocity over time, and this equals this because they are the same thing. You are differentiating distance twice, you are differentiating velocity once to get acceleration. So after all this long story of mine, let's solve this question. So we say the position coordinate of a particle is confined to move along a straight line is given by this. So this is s with respect to t. So we are asked to, we say where s is measured from a convenient origin and t is in seconds. So I say determine one, the time required for the particle to reach a velocity of 72 millimeter per second from its initial condition at t is equals to 0. So we have to look for the time, and for us to get that time here now, we have to find the velocity, because you have to get something that will give you the function of time so that you can from there deduct your time. So what am I saying? You can get your v from here, you can get your velocity from here. How? The s, the t. You are differentiating this s with respect to t once, so it will give you your velocity. So let's start without wasting our time. So we have v, which is equals to the s dt, which is equals to, what is our s? This, you have 2t cube minus 24t plus 6 over dt. And when you differentiate this, what we have? 3 multiplied by 2, that's 6t, then 3 minus 1, that's 2. We all know differentiation very well. So if you differentiate this, you get only 24 back. Now we have gotten our velocity. Did they give us velocity in the question? Yes, they said to reach a velocity of 72 meter per second. Since we already have v is equals to this, we just put this 72 equals to this, because you know v is already 72 already. So from there we have 72 equals 60 square minus 24. So you can bring this one to this side. You have 72 minus plus, it's crossing over, is equals to 60 square, and this should be 96 equals 60 square. So from there you have t square equals 96 over 6, which will roughly give you, this should be 16. If this, yes, it should give you 16. So 16, when you bring this square root of 16 is 4. So your seconds here is 4. You have gotten the time here. That's for that. Then acceleration of particle when velocity is 30. Since v is equal to 30 meter per second, we just bring this, the same thing we did here. The way we insert 72 into this, equated to this, v is equals to this. So we are bringing that same method here. So 30 will now be equals to this now, because v is equals to this and they are giving us v here. This is our velocity. So 60 square minus 24. So remember, we are calculating for acceleration, but we must get time first. So what do we have here? 30 plus 24 equals 60 square. We have 54 divided by 6 is equals to t square. So from there, this is 9. So we have t is equals to 3 seconds. So once we got our t now, we can now look for acceleration. dv dt, remember, dv dt. And what is our v? Our v, this is our v here, remember. So 60 square minus 24 over dt. When you differentiate this, what do you have? You have a is equals to 6 times 2, that's 12t. Then you can't differentiate this, that will give you 0. So from here, since you already have our t here, this is into bracket 3, and it will give us 36 meter per second square. I don't know why I'm saying millimeter, pardon me. So it's meter per second square. So that's our acceleration in this case. This is our time here. Then our last one is net displacement of the particle using interval from t is equals to 3 seconds and t is equals to 6 seconds. We are looking for the displacement, so we are making use of what they give us in the question. And now they are having an interval. So once it's having interval of a lower limit and higher limit, you don't need to stress yourself. You just know that s will be for 6 and 3. That's all. So what are you doing? You bring out your distance, which is 2c cubed minus 24t plus 6, then limit of 6 and 3. And you all know the rule of limits. You are going to insert 6 as t here, then minus. You also insert 3 t as 3 here too. Then you minus and get your answer. So let's just do that. You are going to be having 2 into brackets 6 minus 24 into bracket 6 plus 6. That's for as t is equals to 6. And for the second one now, you have 2 into bracket 3 raised to the power 3 minus 24 into bracket 3 plus 6. So what will that give us there? When we calculate that, we are going to have in this side, you are going to have 294 here. Then this minus, then here we are going to have minus 12 when you calculate this. So you have minus 12. So this minus is turned to plus. So 294 plus 12, that is 306. 306 watts meter. That's the end of this video. Like, share, comment, subscribe. Thank you very much.